Hey Gen Chem students, I'm Ben Asman. Today we're going to mix together an equilibrium reaction and a solubility one to determine a KSP. Let's get to it.
Chemical equilibrium, the solubility of calcium hydroxide. The primary reaction we are investigating today is how calcium hydroxide solid goes into solution. It forms ions. We want to figure out how much calcium goes into solution. Now we know if we add EDTA to calcium, it will create a complex, and it will do so irreversibly. That means it can't go back. And because one EDTA molecule only binds to one calcium, we know that we can figure out how much calcium there was by how much EDTA we added. Now, a main problem with this is that calcium in solution, EDTA in solution, and EDTA complex in solution are all clear, so we can't really tell them apart. So we're going to add one more thing, and that's EBT. Now, EBT and calcium will also form a complex, but they do so reversibly. It can go back and forth. When EBT is by itself, it's blue. When it's complex to calcium, it's red, which means it's going to start off as red. And as we add the EDTA, and as we remove the calcium, we're going to force the reaction back towards the blue. Once it's fully blue, there's no more calcium left, and that volume of EDTA will tell us how much calcium there was. The last equation we need is the KSP. Just like any K for any equilibrium, it's always products over reactants. In this case, our reactant is a solid, so we don't include it, which means the KSP is a concentration of calcium times the concentration of hydroxide squared. It's squared because the coefficient for hydroxide in our main reaction is 2. This provides one last note that you should be aware of. When you're figuring out the concentration of hydroxide from the concentration of calcium, it's going to be twice as much, and then you're going to put it into the KSP and square it. So it's going to be times 2 and squared. Be aware of that.
So we're going to start as always with getting some reagents. We have here our saturated calcium hydroxide solution. You may have to open that up a bit to make sure you can actually get this out. We don't need too much, but we do want to make sure that this is covered because we want to minimize the amount of carbon dioxide that comes in contact with this. Remember, carbon dioxide with water gives you carbonic acid, which will then react with our base, changing our solubility. It's a whole hullabaloo, so just keep it covered. Next thing we have to do is filter the solution, so we will need a glass funnel and some filter paper. Now for this, there's a few different designs you can fold this paper into. The old school kind of fluted shape, this one is kind of annoying and takes a long time to do. And the kind of newer cone-like shape, that folds really nice. That's the one I'm going to actually show you today, how to make that one. So for that one, we're going to take our paper, we're going to fold it in half, but not crease it yet. We're only crease from the middle to one side, so it's only one radius that we're going to crease here. Now we can take our actual cone here, and what we're going to do is we're going to use that crease and which is kind of bend that in to create that cone-like shape like that without actually creasing that. We just want to make sure it comes to the bottom and then fit that in here, and then we can just kind of press that down and then crease it once it's inside, and that will give us the right shape. Now, the problem with this is it does pop out, so what we do for that is we're just going to get a waste container here and a little DI water, and we're going to spray this down, and that's going to make sure it sticks, and then anything extra we can pour away. Now we can take our 250, and again I have something to close that with, put that there, and take our calcium hydroxide saturated solution, and we're going to filter that. Now sometimes you will get a tight seal here, so you might have to lift it, but in general this goes pretty easily. If for whatever reason this does get stuck, you can take a spatula and very gently scrape the sides of the actual filter paper. That should release it. Okay, now that it's mostly gone through, at least enough that more than we need to use, we can dump the extra here in the waste container, you can see, and cover that for later. Next, we are going to grab our EDTA solution. make sure you write down the exact concentration given that day. They're not always the same. Next, we're going to want to fill our burettes, but we got to rinse these first. As always, we have a waste container. We have here, I'm going to close that first and just add a little in. Let some pass through the main spout. And then dump the rest out the back. Do that one more time. Lovely, and now we can just top it off to the mark. Looks like I overshot it just a little bit, so I'll take a little bit out. That looks quite a bit better. So I have set up here a hot plate, added a piece of white paper on top so that we can see this more easily, the color change. We're going to grab this 250 Elmeyer here, put that there.
Just a quick side note, what I found out later is it's far easier to use a 150 than a 250, so I did that for all the future runs.
Add to it a stir bar, that will make our lives easier. And to this, we're going to start off by taking, now to this we're going to take our calcium hydroxide solution.
If it isn't clear, make sure to refilter it.
And we first want to get the temperature of that solution. So we'll take that thermometer, stick that in there. Today is a warm day, so we imagine this will be relatively warm. And we can see here the temperature of our solution. We can now take a 10 ml pipette, and as always, suck a little too much, put our finger there, and then lower it to the mark. Looked out there, got it perfectly on the mark first time. Now let that drain. And as always, we do not blow out the tip. There's still a little bit in there. Next, we're going to take our EBT and we're going to add just a few drops, just 4 here. 1, 2, 3, and 4. And we can start that stirring. Lower this into position. Now we're expecting it to be somewhere in this range.
So we can go quickly until we reach about 8 milliliters, and then we want to slow it down to being 1 drop at a time. I'm going to quickly run through it here. Now if you do go too far, you're just going to see a blip, and that's all you're going to see of the blue. So if you're going quickly, all you're going to see is this little blip here, and that's it. So that's why you want to go slowly. If you go slowly, what you're going to see is something more like this. It's going to start off pink, and as you add 1 drop at a time, it's going to slowly turn to a kind of purplish, and then a dark blue, and eventually a light blue, like that. That's the perfect amount. After that, it's gone. Record the volume, repeat the titration 3 times, and you're done.